Okay, hello hs1 A and B students. Okay, this is first video lesson recorded to you. I think that this form is the most interesting and the best to you. Okay, your homework was to read a chapter related with second Newton's law and related with tension. So as a revision, so let's talk a little about second Newton's law of motion. Okay, so second Newton's law of motion is about force and acceleration. So when force, resultant force, acts on the object, resultant force, so this is the sum of all forces acting on the object, and this is acceleration of the object due to this resultant force. Acceleration means that object changes velocity, so it can change its speed, so value, or change direction of motion. Remember, acceleration is a vector quantity, so it's characterized by two details, two features, direction and value. So let's back to second Newton's law. When the resultant force acts on the object, then object accelerates, and acceleration is directly proportional to its mass. Okay, one of the example in your book was acceleration of the racket or trolley. So simple example: if you have an object, which experiences, let's say, few forces. This is a thrust force, which is, let's say, 10,000 newtons. Okay, and we have, let's say, resistive force. Let's say 2,000 newtons. Then, of course, overall force is difference between the bigger and the smaller one, in the case of value, so 8,000 newtons. And this force creates acceleration of the object, so when mass of the object is known, let's say 2 tons, so 2,000 kilograms, then it's easy to find acceleration by dividing value of force and value of mass, so in this case 4 meters per second squared. Remember that direction of acceleration is exactly the same as direction of resultant force acting on the object. Okay, I hope you are prepared to the lesson. So you have to have your notebooks, a pen, pencil, ruler, and eventually calculator. So if you don't have, please organize it. You have to do a note. You have to work with me, and you can stop this video for a moment. When you will be ready, turn it on again, and I'm writing for next slide topic. Okay, so topic of our lesson is tension. We'll be talking still about second Newton's law of motion, but in the context of tension. And in the case of tension, I mean a kind of force which is connected with along the string, which experiences a force. I'm not talking about emotional strain or something like that. I'm talking about tension in physics. So let's imagine that there is a wall to which a string is attached. Okay, and there is a person which pulls this string or cable, okay, by his hands. So let's imagine that force exerted by the person is, let's say, 200 newtons. So it is a tension of the string. Of course, due to the third Newton's law of motion, a person experiences also a force of 200 newtons. Okay, and we have stationary case, which means that tension must be equal to 200 newtons. Or other words, a wall experiences a force of 200 newtons because it is the same as a tension. Okay, so another example of tension. Let's imagine that we have an object of mass, let's say 2 kilograms, which is attached to the ceiling by an extensible string. So what is the tension of this string? Object acts on the string by force, gravitational force, which is equal to m times g, so 2 times 9.81 meters per second squared, which gives 19.62, I hope, around 19.6 newtons. So tension of the string is 19.6 newtons, because again the situation is stationary object, doesn't accelerate down, doesn't accelerate up, so tension is equal 19.6 newtons. Okay, here we have two very simple examples of tension. These examples are for middle school, not to you. So please copy these two examples. So when you will be ready, please turn movie again, and let's focus on a little bit more advanced examples, a little bit more advanced calculations. Okay, so next example. Let's imagine that you have a flat horizontal surface which is frictionless. Okay, and on the surface you have two objects connected by the string. First one of mass, let's say 4 kilograms, and second one, let's say of mass 2 kilograms. As I said, these two objects are connected by the string, and there is a force acting on these two objects, and this force is equal, let's say, I don't know, what do you want, 18 of newtons. Okay, and the question is, what is acceleration of this system? So acceleration of these two objects. Remember, we have two objects, mass 1 and mass 2, connected together. And what is a tension of this string which connects these two objects? Remember, in this example, the string is inextensible, has no mass, is infinitely thin, so a kind of ideal situation. So how to solve this problem? If you have an idea, please do this now, stop movie for a moment and try to solve it. In a few minutes, let's focus on the problem, copy this and try to solve. In a few minutes, turn it back and I'm going to present a solution. Okay, so how to do this? So let's look. We know that overall force acting on the system of these two objects is 18 of newtons, and mass of the system of these two objects is sum of mass of 4 kilograms and 2 kilograms, so 6 kilograms. We know that when system experiences a resultant force, in this case it is a resultant force because friction is negligible, then acceleration of the system is force divided by mass due to the second Newton's law of motion. Force is given, mass is given, so you can calculate acceleration of the system is 3 meters per second squared. Okay? And now, these two objects are connected. What does it mean? It means that mass m1 and mass m2 both move with acceleration of 3 meters per second squared in the direction of force, so in this case to the right. Okay, so what is acceleration of mass m1? We know that mass m1 has a mass 4 kilograms and accelerates with acceleration of 3 meters per second squared. By using these two data, okay, we can calculate which force acts on mass m1. Force acting on mass m1 is mass m1 multiplied by acceleration of mass m1, so it's the product of 4 and 3, so 12 of newtons. Okay? So 12 newtons is force which acts on mass m1. 12 newtons. So it is a tension of the string. Mass m1 moves or accelerates to the right due to the force. It's connected with mass m2 by a string. So what type of force acts on mass m1? Of course, tension. So what is the tension of this string? Tension of the string is 12 newtons. 12 newtons is the force which acts on mass m1, so this is tension of the string. So what is the answer? Tension of the string is 12 of newtons. Okay? I hope you understand this example. If not, please read it again, copy to your notebooks, stop, of course, stop video for a moment, and when you will be ready, please turn it on again. I'm going to present another example. Okay, example 2. Work with me, copy to your notebook. Again, you can stop video at any moment and turn it on again when you will be ready. So let's imagine a little bit more complicated example. Okay, you have two masses, mass m1, m2, three masses, mass m1, m2 and then 3, connected by two strings, string number 1 and string number 2. So this is mass m1, this is mass m2, this is mass m3. And these three masses experience a force, let's say, of 50 newtons. Mass m1 has a value of 5 kilograms, mass m2 has a value of 5 kilograms, and mass m3 has a value of 10 of kilograms. And again, a very similar question. What is a tension of string 1, so here, and what is a tension of string 2, so here? Okay, copy this, try to solve it working alone. When you stop video, when you will be ready, turn it on again and check your calculations. So in similar way, we can calculate mass of the system is sum of m1, m2 and m3, so 5, 5 and 10, which results in 20 of kilograms. We know force acting on whole system is 50 newtons, so by using second Newton's law of motion, we are able to calculate acceleration of the system. It's 50 divided by 20, which results in 2.5 meters per second squared. Okay, so all of these masses, mass m1 and mass m2 and mass m3, accelerates to the right with acceleration of 2.5 meters per second squared. Okay, so let's focus on string, on first string, at this place. Okay, so let's look. We know that mass m1, which is equal to 5 kilograms, moves with acceleration of 2.5 meters per second squared. Okay, so this force acting on mass m1 is the product of 2.5 and 5, which results in 12.5 newtons. What does it mean? It means that tension of first string is, let's name it ft1, 12.5 of newtons. Okay, it was of course easy. What with second part of the exercise? What with tension of the second string? I'm going to write it here. Oh. Tension of the second string can be calculated by in similar way, but you must be careful because m2 is connected with m1. Or other words, the question is, what is a force which acts on m2 here? Is it clear? Okay, this force acts on two masses, mass m1 and mass m2, because m2 is connected with m1. So, in other words, this force Ft2 moves two masses, m1 and m2, with acceleration which is equal to 2.5 meters per second squared. So you have to add 10 plus 10, 5 plus 5, sorry, which results in 10, and multiply this by 2.5. 10 times 2.5 gives 25 of newtons. So tension of the second string is 25 of newtons. Okay, how to check it? Let's look. You can do similar calculations for mass m3. Let's look. If tension of the second string is 25 newtons, it means that overall force acting, net force, acting on mass m3 is difference between 50 newtons and tension 25 newtons. So overall force acting on mass 3 is equal to 25 newtons. Okay, overall force divided by mass gives acceleration. So net force acting on mass number 3 divided by mass 3 should give us acceleration. So 25 divided by 10 is 2.5, which is exactly the same as we obtained here. Mass 3 moves with acceleration 2.5 meters per second squared, which confirms our method. Okay, so please stop the video, copy this, read this 2-3 times. You must know how to solve it, and after a few minutes turn it back. I'm going to present another example. So example probably 3. Okay, let's imagine a little bit different situation, maybe not more difficult, but different one. Let's imagine that you have a mass m1, which is equal to, let's say, 4 kilograms, which is connected with mass m2, okay, which is equal to, let's say, 2 kilograms by string, but mass m2 is hanged in such a way that it can fall. It cannot fall freely because it is stopped by mass m1, but where is no friction, then system mass m2 moves down and mass m1 moves to the right. This is something like a pulley which doesn't interfere with our system, it doesn't take energy, the mass of this is negligibly small, we don't need to use inertial momentum, etc., etc. So practically the system moves in this direction and your task is to find acceleration of the system. So please copy this, focus on the problem, try to solve it working alone, and when you will be ready, turn video back and I'm going to present the solution. Okay, so let's look how to solve it. Okay, mass m2 experiences a force, of course gravitational force, which is equal to m2 times g, and it can be calculated. But it's stopped by a friction, a tension, not friction, but a tension. Tension of the string. String is connected to mass m1, so the tension of the string at the position of mass m1 is the same as tension of the string at the position of mass m2, or other words, this is the same tension. And this tension acts on mass m1. Is it clear? The question is not about the tension, the question is about acceleration of the system. So which force accelerates system? Of course, only gravitational force acting on mass m2. If mass m2 is given and value of gravitational acceleration is given, then you can calculate, it's approximately 19.6 newtons. You can calculate force acting on the system. And this force is overall force which accelerates system, so this is net force acting on the system. So net force is equal to 19.6 newtons. Okay? So system accelerates because it experiences a force of 19.6 newtons, and mass of the system, of course, is sum of masses m1 and m2. So finally, you have to divide 19.6 by 4 plus 2. So 19.6 divided by 6, 19.6 divided by 6 is 3.26, 3.27 meters per second squared. Okay? So let's look. Again, this example is very similar. This example is very similar to the previous one. Okay? But the direction of force changes because direction along which string is stretched also changes. Okay? Stop video, copy this, read it again, and I'm going to present the last example. Okay, example 4, in my opinion, the most difficult of these examples. Let's imagine that you have a pulley which can rotate to the left or to the right. And along this pulley there is a string hanged, and two masses are connected to the pulley. Mass m1 to the left and mass m2 to the right. Let's imagine that mass m2 is heavier, mass is bigger, so m1 is equal, let's say, 2 kilograms, m2 is, let's say, 3 kilograms. Okay? As 10 meters per second squared, it will be easier in calculations. Of course, system will be moving in such a way that mass m2 will be moving down and mass m1 will be moving up, or other words, this wheel will be rotating clockwise. Okay? And the question is, what is acceleration of the system? Sorry. Okay, copy this, try to solve it walking around. When you will be ready, turn video back. I'm going to present solution. Okay, so let's focus on mass M2. M2 experiences two forces: gravitational force acting on mass M2, Fg2, and of course tension of the string, something which stops mass M2, which slows it down, which decelerates, is a not decelerates, it slows it, is a tension. Okay, tension is a little bit shorter in the case of length of the arrow than Fg2, because overall force acting on mass M2 must be directed down. I'm going to use a pink color to present overall force, net force acting on mass M2. Let's name it F2. Okay, let's do the same with mass M1. Mass M1 experiences tension, which is exactly the same as tension acting, because this is the same string, so I can use exactly the same symbol. And gravitational force acting on mass M1. Gravitational force acting on mass M1 is a little bit shorter than tension, because we know that overall force acting on mass M1 must be directed up, because system is accelerating in such direction. So overall force F1 is directed up. Okay? So now let's look. We can build simultaneous equations. First equation, which is related with mass M1, that overall force acting on mass M1 is difference between tension and gravitational force acting on mass M1. I'm talking about this. Yeah? Or other words, I'm going to present the picture here. M1 experiences tension acting up and shorter gravitational force acting down. So overall force acting on mass M1, F1, it must be directed up. So this is the origin of this equation. And I can write exactly the same for mass M2. M2 experiences overall force F2, which is a difference between Fg2, sorry, it should be 1 here, okay, Fg2 in this line is of course 1, in second line is 2. And tension, which is the same as in first. Why? I'm going to create this diagram. I'm talking about this part of the exercise. So tension is acting up. Tension is acting up. Gravitational force, which is longer than tension, acts down. So overall force F2 is directed down. So this is why this equation. Is it clear? But of course, M1 can be written as M1 times G. Tension is tension, and Fg1 as M1 times. Sorry, next mistake, sorry, let's back here. M1, F1, what is F1? Due to the second Newton's law of motion, F1 is M1 multiplied by acceleration, tension is tension, and Fg1 is M1 times G, and I can write exactly the same for second mass. F2 is given as M2 times acceleration, is equal to M2G, because this is Fg2, minus tension. So finally, we have two equations. First, M1A is equal to Ft minus M1G, and second, M2A, which is equal to M2G minus Ft. Okay? Acceleration of both objects is the same, both are connected by the same string. Masses and G are given, so there is only one unknown. What is this? There are only two unknowns, the tension and acceleration. Okay, I'm going to continue with these two equations here. So let's substitute. M1 is 2 times acceleration is equal to tension minus 2 times G, which is equal to 10. And second, M2 is 3 times A is equal to M2 times G, so 3 times 10 minus tension Ft. Okay? And all you have to do is solve it. So let's solve it. We have Ft from first, which is equal to 2A plus 20. I move this to the other side and substitute to the second one. So 3a is equal to 30 minus 2a minus 20, because ft is 2a plus 20, so minus ft will be minus 2a minus 20. So finally 5a is equal to 10. Is it clear? 3a plus 2a is 5a, 30 minus 20 is 10, so acceleration is 10 divided by 5, so 2 meters per second squared, and this is the answer. Acceleration of this system is 2 meters per second squared. What does it mean? It means that mass m1 moves up with acceleration of 2 meters per second squared, mass m2 moves down with acceleration of 2 meters per second squared, and of course this wheel is rotating with linear acceleration on the edge, which is equal to 2 meters per second squared. Stop video for a moment. I hope you understand everything. Okay? Stop this, copy this, focus on the problem again, read this 2-3 more times, and when you are finished, I'm going to give you a homework. Okay, so in similar way, you have to solve the system. Very similar. We have again two masses, m1 and m2. m1, which is heavier than m2. Okay, and m1 will be equal to 2.51 kilograms. m2 will be equal to 2.12 of kilograms. You have to use gravitational acceleration as 9.81 meters per second squared. 9.81 meters per second squared. And you have to solve this in similar way. The task is about what is acceleration of the system. Remember, system will be accelerating counterclockwise because m1 is heavier, so it will be falling, and m2 is lighter, so it will be accelerating up. And one more, and what is a tension of the string? Remember, tension means here or here at any point. It's the same. Okay, thank you for your attention. Copy this is your homework. When you will finish, send me via email. Just scan it or make a photo and send me via email. I hope this form of communication is not bad. And good luck. I'm waiting for comments. Bye.